Hey folks, welcome back to the channel. Hope you're doing well. Thanks for joining me today. This right here is the LG 16H Prime high voltage battery. It is a 16 kilowatt hour battery rated at 400 volts nominal voltage. I'm going to show you how to assemble this and some of the specs and features on it here today. See that there? Those are two LG high voltage batteries, and those are 410 pounds each. So each pallet weighs 410 pounds, and that one right there has the transfer switch on it, the grow watt transfer switch. So I need to open them up, and I'm really hoping that I can take boxes out of there. Well, we're gonna open up this first box here and see what we got inside. Let's see what this is. Oh, I see multiple boxes. That's a good sign. Here we go. It says, well, that's super light. And that's probably gonna be the heavy part. Yes. There you go. We have two boxes. Two battery modules. There you go. Here is your battery module. Not too bad. There's two of them. And then those two boxes are on top. So this is what you're going to see when you open up this crate. There is one of the battery cells right here. Not much to see. So that's one battery, two batteries, and then I have the transfer switch. Oh yeah, no problem. There you go, just like that. All right, so I'm gonna save you all the unboxing of everything because I had some really beautiful footage of all that, but my audio cut out, so I didn't have any audio on all of it. So we're doing this again a little quicker this time. Behind me, everything is out of the boxes now, and I will go through everything that comes in the box so you can see it as it lays. So here we have our two battery modules. There's an A and there's a B. And if you look right on the side in the serial number, the last digit is A or B. You'll need to know that because they go a certain way. These rivets here, or these screws, is considered the rear. The smooth side is considered the front. So when you put these against the wall, they go a certain way. That is your wall plate. Cast aluminum wall plate. Pretty straightforward. Here's your bracket. I already mounted that to save you the trouble. There's measurements on how high to do that in the directions. This is your control unit. This is the cover for the control unit that goes on top. These are the brackets that go down there on the sides that hold the battery bases together. These are these long screws that hold the control module head on top of both the batteries. And these are a bunch of stainless steel screws for the wall bracket, which attaches the top of the battery to that wall. And then the rest of the screws go in here. So, and then you also get two spacer blocks. They're both supposed to be this long. I broke this one, but it's okay because it still works. So, I'm gonna throw you back on the tripod now, and I will go through the assembly process and what order to go. Also forgot, you get an owner's manual, some mounting hardware, and some communication plugs there that will be used to communicate with the inverter. A set of zip ties, and you get a set of plugs for the seal tight or pass-throughs for the side of the control module. Step one is going to be mounting that wall bracket, which I already did, as you can see. Step two is they recommend to take this guy, put it against the wall, and then put it behind your mounting bracket. That gives you the space for your base away from the wall, so you don't have to try and slide it closer to your bracket when you get everything assembled. So, first step, we're going to take module B. We're going to put the rear of it facing me. So the front of the battery will actually be towards the wall. There's two little inserts here. It's got it labeled. This is where you pick them up. They are pretty heavy. They're not as heavy as obviously an assembled battery, but they're still heavy. So you want to set this in the base really carefully. There's little notches for it, so it'll just drop right into place. There we go. There is one. And then the A module, the rear of it will go to the rear. So we're going to put that one in there now. They just sit right in there, and you can see at the bottom they look nice and smooth. They're together. Next thing we do is take our base brackets, these little guys here. They're going to go this orientation up. They'll fit on the side bottoms, and we're going to grab some of those short stainless steel screws. We'll get them all started on both sides, and then once we get all 12 of them in, we'll tighten them up. Just going to take a couple here and start getting them lined up. These are a 10 millimeter socket head. Pretty straightforward. And you may need to adjust your battery base just a little bit here and there, but that's why you leave everything loose. Just kind of get them started. This is what we got going on. You can see the base screw holes and then the battery base screw holes. There's a locator pin for these. Just pops right in there, and then we get our screws started. And once we get all 12 in, then we'll tighten them up. All right, so got all those screws tightened down. All 12 of the screws on the bases there are done. The next step is to take your spacer blocks used for assembly and disassembly, and you place them right here, top up, right on this line that says place the spacer in the line here. So what that's going to do, that's going to have somewhere for this guy to sit on while you make the connections into the batteries. So I'm going to get this plopped up there. This is not real heavy. It's pretty light. You just set that on there like so. And then I'm going to bring you in and show you those connections. All right, so here we are on the sides. And what we have is your battery power. As you can see, it just gets put right in there. Your little click, and then what you do is this little red tab is pushed down, and that's a locking tab, so it does not, it verifies you have a good connection, and it also keeps it from popping out. And then this guy here is your communications. There we go. Both of them, and it's the same thing for the other side here. There's one side, there's the other, and the same thing back here with this guy. That clicked, then we push down our little locking tab. All right, now it gets a little tricky because we got to pick this up and take these out. All right, so we're just going to pick up one side, take out our block. We kind of got to finagle a little bit because when you do this, the wires on this side are, which is how I broke the other one. You might want to get an extra set of hands for this one. There we go. There. It just sits down in there. The wires will kind of fall into place in there. We're good to go. Okay. So now what they recommend to do is just to make sure your connections are good before you go any further, is to come in here and flip on your breakers. All the lights come on. There's 2 greens, a white, and a red. And after a little bit, all of them will go off except for 1 green light. That verifies we have good communication between both A and B cells to the control head. And if you let it sit long enough, that 1 green light will start flashing on and off because there's no communication to an inverter, which obviously we don't have hooked up. So after you get the green light, that means we're good. We're going to power it back off, and we're going to continue the assembly, which is almost done. We're going to grab these 6 super long bolts here. These are a 5/16 nut driver here on top. And there's 3 down each side. They just drop right in there. We're going to put all 6 of them in their corresponding slots. And then what we need to do is we need to start all 6 of them carefully. Once you get them started, just finger tight down. Because like again, you want to make sure all of them are in place before you tighten them down. Just makes everything go a little easier. Like this one, I need to wiggle around on the module a little bit. Okay, so all 6 of them are started, so I'm just going to go ahead and snug this one down. And what this is doing is there's gaskets on top of these battery cells. And by doing this, it's compressing that gasket to make this water resistant, which is why it makes it an outdoor unit. This whole top part is sealed. The battery modules are now sealed to the control head, so no water can penetrate. Okay, now next is going to be the wall bracket. And I'll bring you in closer for that one. All right, so we're going to grab our wall bracket here. We're going to set this on the back part here. You can see all the holes line up. They do give you slotted holes in the back for a little bit of leeway. These are those 6 bolts that we just put in right here. And now I'm going to go ahead and get those screws in. And then after that, we put that cover on top of this. All right, so here is our 6 bolts for the back where we attach the wall bracket to. Okay, so those are all tightened down. Next, what we're going to do is we're going to throw this cover on. And this cover has 4 of the 5/16 head bolts on it. All right, and there's one more thing here that I can show you. There's 2 3/4 inch threaded outlets here, and those are for running your wires out through seal tight up to your inverter or to another battery if you're paralleling. Here we are at the front of the battery open. We're going to pull this cover off and just give you a brief look at what is inside the cover, what you can expect for wiring terminations inside of here. Oh, sorry about that. Okay. Obviously we have our breakers on this side. They are all tied together, so there's no single leg tripping or anything like that. We have our battery power, which will leave here, and that will go out to our inverter. This is our internal communication. This is the inverter communication terminals over here. And then we have our dip switches for our resistors for first or second battery, and then if the communications are on or off to our inverter. Pretty simple, not much to it. Small little strip there. Obviously, this should all go pretty quick, pretty easy. So I'm gonna get this closed up and we'll give you a little closing here. These batteries are slightly larger than the EG4 280 amp hour 48 volt batteries. Those only sat about yay high. These are about 6 to 8 inches taller. They're about the same width. They're a little bit deeper as well, and they are much heavier. They are about almost 100 pounds heavier. These batteries are 375 pounds versus the EG4s is about 285 pounds. So there is a little weight difference, but you do get more capacity, and they are a high voltage battery, a 400 volt, which makes them really cool. It is rated at 7,000 watts continuous output. And if you parallel two of them, obviously you double that, you'd have 14,000 watts continuous output. With an EV charger, you can charge about 30% faster with this high voltage because you're not converting it from such a low voltage of 48 volts back up to a high voltage to charge your car or truck. These obviously, with two of these, you have more capacity, more storage capacity than two of, let's say, the EG4 280 amp hour batteries that I had up here before. The other cool thing with these batteries is because they are a high voltage, you are able to run a much lower wire size. I'm sorry, a much smaller wire size to your inverter. This is my transfer switch. I'm still waiting on my inverter. I'll be getting that tomorrow, but here's some 8 gauge wire. This is all you need to go from your battery to your inverter. Why is that important? Because it's such a lower cost versus your big 2-watt cables that you normally have with a lower voltage. It makes crimping on lugs much easier. You can do that with just a normal, smaller handheld crimper versus a big mechanical or hydraulic crimper for your large 2-watt cables and your mechanical lugs. These you can just crimp on some ferrules, low cost wiring, low cost ferrule connections. You can put these batteries much further away from your inverter if you have to, because you can afford to with the smaller wire. You're not running 20 feet of 2-watt cable at, I don't know what it is, $7-10 bucks a foot, something like that, for a good quality cable, versus your 8 gauge wire, which you can buy a roll of it for fairly inexpensive. Smaller conduits, if you're running, out of your batteries across the room to your inverter, smaller conduit, less cost. There's a lot of cool things. I mean, that's just one thing that's cool about these batteries, is that you have a much higher conversion rate too. They're more efficient converting it from 400 volts to your 220 or 400 volts to your 240 in your household wiring. Sorry, mosquitoes are out. Versus going from such a low voltage of 50 volts or 48 volts up to your 240. You lose some efficiency there, and then also the same thing with your solar panels. Your solar panel strings are usually around that 300 to 500 volt range, and if you're bringing in that power through your inverter to your batteries to charge them, you lose efficiency there, dropping them down to 48 volts. Whereas with the LG high voltage, you're almost the same voltage coming in from your solar panels going directly into your batteries, which is just a much more efficient system. So, being that higher voltage, the overall installation cost of these batteries for a do-it-yourselfer is going to be much less. So these batteries right now are around $2,800 from Signature Solar. They are linked down below in the description. If you have any questions, you can go there, check out the description. But more storage, more power storage, being a 16 kilowatt versus a 14 kilowatt with the EG4 wall mounts. And the battery costs less to start with than the EG4s. I am not dissing the EG4s by any means, because I have a bunch of them and I love them. They work great, they're solid. The problem with the 400 volts is they're only capable with certain inverters because it's the high voltage. Most of your inverters out there today are for a 48 volt system. There are a few. There's a Solis, there's the Grow Watt, which I'll be getting tomorrow as a Grow Watt, 11.4 kilowatt, that are capable with these, or compatible with these high voltage batteries. They don't cost anymore. Those inverters are still around the same cost per kilowatt as the rest of them, but you have to make sure it's compatible with the battery. So just want to get that out there. I'm going to link all this stuff down below in the description. Check it out. I have a coupon code down there for you through Signature Solar. That'll save you some money on everything. Check out Signature Solar. They always have great deals on stuff. They're running sales constantly. Use that coupon code. It helps with the channel. I really appreciate it. Thank you everybody that has used the coupon codes. It doesn't go unnoticed. I appreciate it very much. Thank you. There's our second delivery of the day. XR Iron Ridge mounting rails. Second truck that's been here today. That's pretty fun. These are the Iron Ridge, I don't know, XR100 brackets, bonding splices, S5 corrugated steel mounts, all the rails, 84-inch rails, all stuff for the barn.